In this lecture, we're going to continue discussing software validation and testing. In particular, we're going to look at unit testing and then look at how to use JUnit so we can accomplish automated testing within Eclipse for our Java projects. As you have probably discovered, as you have been writing your code, coming back and testing it is not the most exciting thing in the world. Part of the reason is just because you got to run through so many different variations of your code, and then if you make a modification, you got to go over and make that again. And then it's also hard to think about how to use it in as many variations as possible. And we always must keep the mindset that other users, particularly end users, if we're developing a whole application that they're going to use, are probably going to use the software a little bit differently than you do. And so one of the challenges in testing is trying to think how other users may do that. Now, as far as testing scope, we can look at this here on three different levels. We can look at that on the unit level, where our unit's going to be considered a method, so where we're going to test each individual method of our class. We can look at integration, where that's going to be the interaction of our modules or the interaction of our classes working together as we're building our system. And then we can look at our end product, our complete application that we have built. So we can have testing that can occur on all these levels. Remember, there are different types of testing associated with that. In the article, What is a Good Test Case? It gave a good overview of some of those different types of testing, where we can have our unit or function testing. We may have specification-based testing. We may have stress testing, regression testing, user testing, all kinds of different testing going on. We're going to be focusing on unit testing, where we're going to be testing the individual methods of the class that we have written. When we start talking about this, we can look at white versus black box testing. White box, or they may refer to it as a glass box, this is where you're developing the test cases based on the internal knowledge of the software. In other words, you can see the code in front of you. You can see that there's a multi-branch if statement. So then you're going to write test cases based on that knowledge so that you'll test each branch of that if statement. Where black box is, you're just going to have maybe some functional specifications, but you can't see the internal workings of the code. So you're going to write the test cases strictly based on the specifications. So this is going to be done more from the user's point of view. And when you're writing black box tests, they may not test each program path. Now, when we are writing code, we want to write white box tests so that we're going to test each individual program path that we have within our method. Now, just some notes to keep in mind as you are testing. One is to test incrementally. In other words, test as you are writing your software. Don't write it all and then come back and test as you're writing a method. Test that. There's even a school of thought out there called test-driven development, where you write your test cases first, you write your automated tests first, and then you let that guide you in actually coming back and coding your method. Consistently run all the tests in your system. Realize that anytime if you come in and fix a bug, that it may break something else. So go back and rerun all your tests. This is called regression testing. Then make sure you write tests for the areas of code that will most likely break. I know we like to think that our code's perfect and we just want to run sort of the typical scenarios, but where the frustration comes in and the errors come in are at those typical boundary conditions. And then we're going to learn today is how to write testing code to help automate this particular process, because testing is so boring and tedious. So when I start talking about automated testing, what we're trying to do here is write a program to perform the test for us. If we write a program that are going to perform the test for us, then we're more likely going to thoroughly test our code, and then when we make a change, go back and rerun all those tests again. So to do that, we're going to use a testing framework, which is just a program itself that runs, that is used to build test cases and then go and execute those particular test cases. If you're going to use a testing framework, it's going to include standard ways to specify the setup. Remember, when we're talking about a test case, it has some initialization conditions. It actually has a set of input values, and then we have an expected results. So we need to be able to set up our object to how we're going to test it. We then need to be able to run individual tests or run all the tests that we've created. We need to be able to analyze our output for our expected results, and then be able to see whether our test failed or not. A testing framework is going to provide all this to help automate the process. A commonly used testing framework, or what we call the X unit frameworks, where the X is going to represent something for the particular language. For example, for Microsoft.NET with C# and the .NET languages, the testing framework is called NUnit. For Java, it's called JUnit. There are unit testing frameworks out there for nearly every language, and here's a link where you can see that there's some out there for Python, Ruby, PHP, pretty much any language has got a testing unit framework available with it because testing is such an important part of it. So what is JUnit? It's just an automated testing framework where you write the test cases as program code. And then the benefit of that is once you write that as code, you can then come back and execute them using the JUnit framework and just rerun them easily. So it's sort of a write once, run many times application. So it works by creating a test harness where you're creating objects to test methods of a class. Then you run the tests, and then it has a tool to actually display the results. So I've come here within Eclipse, and I have written some test cases for a student class that I'm going to test. And once I've written this, I can come up and actually run these particular tests. So I can click on Run. What it then does is it's going to go through and run each one of the tests that I've written, and then it's going to display the results. Here it says I've run 5 of 5 tests. I didn't encounter any errors. And so everything shows up green here, and then I can look and drill down and see the individual test results. So this is a way to actually get some quick visualization of the tests that I've run and what the results are. We'll come back more and look at this in a little bit more detail a little bit later in the lecture. What are the basic steps in here? We create a class within the project that is used to test the methods of another class. Since we're creating a class, we need to give that a name. A good naming convention is whatever class I'm testing. For example, if I'm testing the student class, then I want to call it student test. If I'm testing a car class, I want to call it car test. Whatever the name of the class is, I'll name that class with tests at the end of it. Within this testing class, then you're going to add a method for each test case that you want to run. So your test class is going to have a bunch of methods within that. So if you have 3 test cases, then you're going to write 3 separate methods for those particular test cases. And then once you have written your test cases, you can come back and run an individual test case where you can run all the test cases. You then have a visualization to see if that test case passed. If the test case failed, then there's an issue within your code that you're going to need to come back and address. Writing a test method. There are 3 basic steps here. One, we need to set up an object of the class that we're going to test. This is where we're going to initialize the data members, put in the specific scenario that we're going to be testing. Then we're going to call the method that we are testing, and then we're going to analyze the results and compare them with what we expect to see if they're correct. So if I come back over here to Eclipse and look at a unit test that I've created, what we're doing here, this one's called test adjust grade is 72 by 10, new grade within grade range. We'll talk more about why we use such long names in a second. But what I've done, because I'm testing a student class, I create a student object. I set up how I want that student object to be created. So here I passed in a name and a grade. Then I am calling the method that I'm testing. In this case, I'm testing the adjust grade method, passing in the parameter here. Then I come out and I'm going to analyze the results. In this instance, adjust grade is supposed to take 72 and increase it by 10 to be 82. So then I'm going to say, does the result I get, so I call the get grade method, it returns a value. I see if the value that it returns after calling adjust grade equals 82, which is my expected result. If this ends up being true, then my test case passed. If it's false, it failed, and then I'll get a red mark over here that that particular test failed. So as I come back here, we typically write test cases using the specifications and then using the internal knowledge that we have of our code when we're doing unit testing. Here's a method. It finds and returns the maximum car price in a list of cars. So the method is just find maximum price. So then I want to then write some test cases that are going to test whether this method works correctly. if I've got a class called CarLot that has a find maximum price method in it, the name of my class is going to be CarLot tests. And then I'm going to create a testing method. It has an annotation of @test at the top of that method to let it know that this is a test method. I give it a name. Then I set up my object. So here I'm making a new CarLot object. I am then calling its addCar method to add a car to that. Then I call the method I'm testing. I'm calling the find maximum price method. It returns me a value. Then I come in here and I call assert equals, and then I'm going to compare the return value to my expected result and see if that's true or not. One thing I want to note here is when I'm comparing doubles, the assert equals, we need to pass in a threshold, because when you're comparing doubles, the way it stores those doubles, there's not always going to be an exact match on that. So you'll set up a threshold value to say, yeah, these two doubles are equal because they're close enough in the way that they're stored internally. So I set up a threshold here saying that if this value and that value are within this threshold, then those two double values are considered equal. For ints, because the way it's stored, you can actually see if it's an exact match. You don't have to pass in this third parameter to compare integer values. So this is one test case where I'm testing for a single car and making sure that if I just have one car in my list, that it's going to return the correct maximum price. Then I've got another method here. This is another test case. So I've got test find maximum price car, 3 cars, the most expensive last. Notice here that my method name is very, very meaningful. So just when I look at that, it gives me a good indication of what my test case is testing. I create a new object or CarLot object. I add my cars. I call the method. Then I'm verifying that that method is going to return what my expected result is. When I run those test cases, it treats each one of these methods independently. So it's going to run this test case, then it comes back and it's going to run this test case completely separately. So in here I need to reinstantiate my CarLot object because these are 2 separate tests. When I then execute the tests, they're going to just have a pass-fail result. And please note, if the test does fail, do not move on until you fix the issue. That's the whole point here of using a unit testing, is that you find your bugs early and you catch them before they can be included in a later version of your software. So let me come back to the Eclipse project here, and let's come back to the student, and let's say that I actually have introduced a bug here. Let's say that I was going to have anything that was greater than 99, which this code would still work, but for some reason I put in greater than or equal to 99. Now I have introduced a bug, and this is why we test on boundary conditions, because it's really easy to have a mistake instead of being like greater than or greater than equal to, getting those mixed up. So if I come back now, I've made a modification, I can come back, I can then rerun these tests. When I rerun those, notice that I do get now a red bar that means one of my test cases failed. And it comes up here and it says there's one failure. I can then come here and look at the individual test case that failed. And it said here, assert equals 99, student grade. So I can look now and see which one of my test cases failed. So that should give me some indication of maybe what is wrong with my code. Then I can come back and change my code. In this case, this statement will also work, or I believe it should. So if I come execute my test cases here, so if I come up here and do run, it's going to run those as I wanted to run my JUnit test cases. It goes, runs all those. Notice now that everything passes, so I've got the green light. Writing testing code. I do want to note a couple things. Writing testing code even itself is very laborious because you have to write a separate method for each test case, and you may have several test cases for a method, and then particularly if you have a lot of methods within a class, you're guaranteed to have lots of test cases. When you're doing that, you'll probably notice that there's some similarities for each test case, that you may be setting up the object the same way. So JUnit provides a method called setup, which it will be invoked before each test case is run. So you can put some common setup of your object within that particular methods. So if I have 3 different test case methods, then that setup code will be executed before each one of those test cases. So it will be executed 3 times, once before each test case method is run. This type of thing where we got this set up, there's actually a teardown method too. These are known as test fixtures. They're a great thing to help in the writing of your test cases. There are a couple of different ways that you can indicate to the JUnit framework that you want to run a setup method or a test fixture method. One of those ways is to have your test class extend the JUnit framework test case class, or you can use the at before annotation. So if I come here, let me show you an Eclipse here, and either way is just fine. Let's come back to my student tests here. And in here, let's say that I wanted to run this setup method. One way to actually do that is put the annotation at before. Now notice when I first add this, it doesn't know what it is. So I need to import the before from org JUnit. When I do that, for whatever code that I'll commonly put in here, so in this instance, what I would probably do is now I would create a private data member. Notice I use the student object over and over and over in each one of these methods here. So I'm going to just say private student a student. Then in here, what I'm going to do is say, do my construction of that student object. So I can come here and say a student equals new student. So what that means now down here, in this, each one of my unit tests, I can get rid of these particular lines of code. Because when I come back and execute my test cases, before it executes each test case, it's going to come up and execute the setup method, or in fact, it's going to be any method that has this at before annotation above the method. So I could call this initialization, but it is common convention to call it setup. So that what that does is it allows me to take all my duplicate code that I may have and put that up in just one standard location. Notice in this instance, I did need to create a data member of that class, so that data member will be accessible within each one of my test methods. Either way is fine. It's just a way to help expedite the writing of your test cases. Now, I mentioned there's 2 ways to do that. The other way is to actually come in here, and instead of using the at before annotation, which by the way is the one that I would recommend to use because it's real easy just to add that at before, but you can say that this class extends the test case class. What I do then is come in here, and let me import JUnit framework test case. Now my test class extends that, which means I can come in and override the setup. And the setup method is the method that gets called. Before that, since I've overridden it, this method will now be invoked before each test case is run. Either method is fine. I prefer the at before, but if you see an example code out there, this extends test case, that's what they'll maybe using that for, is to use some of your test fixtures. Now notice in our test cases here, the last thing that we had was an assert statement, and this is where we're comparing our results. Within the JUnit, there's an assert class, and there are several methods available within that class. So here I brought up the API, and I've got a link to that in the PowerPoint slides, but you can see all the different methods that we can call to help verify our results. We're going to use that by using one of these methods here within the assert class. Most often we'll probably use an assert equals, but there's several methods available for us to check our results. Now I want to talk about a test code within the Eclipse project and how do we go about including JUnit and unit testing within our Java project within Eclipse. First note, JUnit is a part of the Eclipse IDE for Java developers. So there's nothing new that you should have to install to use JUnit for your Java project within Eclipse. Now there are some conventions that are commonly used. One of these is we place all our tests within a test folder. All right, so if I come to my Eclipse project here, and I've got several different Java projects in here, I've got my class roster, I have my source folders and the particular packages and classes that are defined within that. And I have made a new folder called tests. Within there, I then make a package name that's going to be equivalent to the class that I'm testing. So here I've got a student class, so I'm calling it edu uwg students.test. This is going to be the package that contains all my tests for this student class. Then within there, I can actually make a student's test class and put my testing code within there. Now again, notice the name of my testing class is the name of my class called tests. Now there is a school of thought out there that to create a separate class for the sort of the category of tests that I'm doing. For example, anything that's related to the creation of my list, I might say student create list tests. Anything that's related to removing items, I might make a class called student remove items from list class and put all my tests there. I'm of the mindset for these type of projects that we're doing is put all our test cases within just a single class. Now, this can get a little bit overwhelming, and so that's why there's that other school of thought where you create classes based on the category of testing. But for our purposes in this course, I'm happy just having a single test class for each class that we're testing. Eclipse will help you generate these test classes. So in here, I have went ahead and made my test folder. But let's say I want to add a new test class for testing my roster. So I can right click on my test class and say new, come down here to JUnit test case. Then I can say what package do I want this in? I'm going to have a separate package for my roster test. So I'm going to call this edu uwg roster tests. Then I'm going to name this. So I'm going to name it roster tests. If I want any setup, teardown methods, any test fixtures to be used, I can go ahead and click on those if I want. So let's say I actually do want to have a setup method. Then I'm going to put class under test. What I can do is click on browse, come up here, and start typing in the name of my class. Now I've already done this before, so that's why roster is showing up, but I could start typing in R, and then it's going to show me every class that I could have accessible to test that begins with R. So I can type in roster here, select that. Notice that brings in my package name. I've got the roster class. The next thing I want to do is click on next. Then I can say, what methods do I want to test? Now, you can write your testing methods from scratch, but this will help stub them out. So let's say I want to test the add student and the create student methods, so I can click on those and I click finish. What it does is it comes in here, creates a new roster test, unit testing class. It sets this all up. It set up my setup method for me, putting the at before annotation. It set up two testing methods, one for create students and one for test add students. So it's at least stubbed that out for me. Now, if I come here, I'll go ahead and run these. Since I'm in this particular class, I can just click on run. It's going to run those. It's going to say that they failed, and there's actually a statement that says failed because I haven't implemented that. Now remember, I'm going to have more than one test for my create students, but at least this has stubbed out something that I can copy and paste. So Eclipse can help you in this particular process. Now if I come back here, I can click on tests, do a right click on that, come down to run as, and then run as a JUnit test. And that's going to come through and run all my JUnit tests. So whatever level I click on, I can click on and run all my tests for my project, or come down to a class, or even within a particular method, and then just run an individual test or all the tests for a particular class. So it's a very useful tool, this JUnit plugin within Eclipse. The last couple things I want to touch base on are just some guidelines. before using a test harness to test your code, first use the specifications or look at your code to write out all the test cases. Now, be mindful again, you'll probably learn about this when you take the software development sequence, but there is a school of thought out there that's called test-driven development where you actually write the test cases before you write the code. It helps actually produce some more robust code, but for our purposes right now, you'll probably have a method that I want you to write test cases against. When you write the testing code, use very meaningful method names. Notice here we got public void, test find max grade, 2 students, max first student. That way, when the test fails, if it fails, then I know right away probably what's going on there. You'll also notice if we go back and we look at that testing classes, we don't have a lot of comments in here. Most of that because the code is very sort of step-by-step because you're only testing one thing at a time. And this is code that once you've written this, you're not going to come back and modify this again. So you can get by with using very few comments and having no specification headers on these test cases, particularly if you use very meaningful and very long method names that indicate what you're testing here. Notice we will never call these. These are called automatically by the testing framework. After you write an individual test method, make sure you execute the test, and then if it passes, great, move on. If it fails, after you write that, then go fix the bug within your code before you do anything else. That's the whole idea of this unit testing is once you find a bug, you fix it before you move on and do any other development. Now, the last thing I want to mention is that there's a common question that comes up. Do I need to test getters and setters because those methods are so simple? So my rule of thumb is there's no need to test getters and setters if the only thing they do is return or set a value. In most instances, that's going to be the case. But if you come in and you modify a getter or setter, maybe to do some range validation, then you need to write testing code to test them. So that's the end of this lecture. And in the assignment for this week, you will get some more practice with this.